We will now discuss integration by parts. So the product rule tells us that the derivative of a product ux vx is the derivative of u times v plus u times the derivative of v. Integrating both sides gives us that uv is equal to the integral of u prime v plus u v prime. And then we can rearrange that to get that the integral of u v prime dx is u v minus the integral of v u prime. So this is the idea behind integration by parts. We're going to have an integral that has a product. One will be u, the other part of that product will be dv, and then we'll be able to find the integral by evaluating uv minus the integral of v du. So for example, let's look at x e to the x. So one of the best things to make u are powers of x. That would make dv e to the x dx. To find du, I would take the derivative to get dx. And to find v, I take the integral. And the integral of e to the x is e to the x. So this integral is u times v minus the integral of v du. And this is much easier to evaluate since I know the integral of e to the x is just e to the x. So I have the integral is x e to the x minus e to the x plus c. Let's do a second one using x squared. So once again, a good thing to be u are powers of x. That would make dv equal to e to the x dx. So du this time is 2x dx, and v would be the integral, which is e to the x. So I have u times v minus the integral of v du. So 2x e to the x dx. So I'll rewrite this as negative 2 times the integral of x e to the x dx. So I now need to actually do this again to evaluate this new integral. Luckily, we just did it. And this is what we got, x e to the x minus e to the x. So this is 2 times x e to the x minus e to the x. So I have x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Let's now look at x cosine x. So once again, I'm going to let u be equal to a power, and v will be equal to then cosine x dx. This means that du is equal to dx, and v would be the integral of cosine, which is sine. So this is now u times v minus the integral of v du. And the integral of sine is much easier to evaluate. So this is x sine x, and the integral of sine is negative cosine, so plus cosine x plus c.